Hey there everyone, Mr. Dickin here, and this is going to be our last lesson for linear programming. And the whole purpose of this video is just to show you guys and kind of explain the answer key file that you'll have access to that'll be linked to Google Classroom in the course schedule and all of that. So we're not going to go through every single problem on that packet. You'll have access to the answer keys, but I do want to go through just a few of the problem answer keys, so that way I can explain how some of this work came to be, and hopefully that'll alleviate some questions that you might have as you're looking through the answers. So before we get too far into this, let's just quickly go back and revisit the whole idea of graphing a line in standard form. So this right here, this is an equation of a line in standard form, where you have x, then y, then equals some constant number. Now, we could rearrange this if we really wanted to into slope-intercept form, so little y equals mx plus b, and that's perfectly legal. However, I would argue that it's also completely unnecessary. So what we can do is use the advantage that this is written in standard form and just figure out the x and y intercepts, so the x-intercept and the y-intercept. Now, if I think about what it means to be an intercept, that means it's on an axis, right? So an x-intercept has to be on the x-axis, so it's going to be some mystery x value, but the y value is going to be 0, right? If it's on the x-axis, if it's on this line, it hasn't gone up or down at all, so the y value has to be 0. Using that same logic for a y-intercept, if it's on the y-axis, the x value is 0. And now our job is just to figure out what should go in these blanks. All right, so now to do that, all you have to do is, let's say we want to find the x-intercept first, is ask yourself, okay, if y was 0, if I did 2 times 0, well, that's just 0. So that whole term is just going to kind of be nullified. And I'm left with the equation 3x equals 30. Well, that's pretty easy to solve for x, right? 3 times what would be 30? That's going to be 10. So my x-intercept here is going to be 10 comma 0. Same thing for my y-intercept. I'll pretend that x is 0, right? So if I plugged in 0 for x, anything times 0 is just 0, so I can ignore that. I have 2y equals 30. If we cover up the x value there, so my y-intercept is going to be 15. So then when it comes time to graph those, let's see here. My x-intercept is 10. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to run out of space. I'm going to count up by 2s. So if I count up by 2s, this would be 2, 4, 6, 8, 10 would be right here. Do the same thing on the y-axis. 2, 4, 6, 8. This is 10, 12, 14. This is 16. Oops, that's a 6. A gross one, but a 6 nonetheless. Okay, so then when we want to graph this, we can just put dots at our intercept points and play a little connect the dots. So 10 comma 0 on the x-axis, boom, right there. 15 comma 0, boom, right there. And then all I need to do from here is just connect them with as straight of a line as I possibly can get. So, boom, right there. And that's how we would handle that. All right, so now let's take a look at the answer key. Excuse me. All right, see, this first example we did in a previous video, so I'm going to go ahead and bypass that. And let's take a look at example number 2. And surprise to nobody, this is not my handwriting. This is the handwriting of Miss Thestu. So if you're admiring the penmanship, she gets all the credit. I did nothing for this. As you guys have seen from my videos, the penmanship is not the greatest. That's why I stick to numbers, not letters. All right, but I digress. So for this example, we're talking about food and clothing that are being shipped to a natural disaster. We have constraints here where we're limited to weight and volume. Now, as we've talked about, the last sentence is going to tell you what you should use as your variables. It says how many cartons of food and clothing should be sent. Well, that tells me my variables. Let's figure out cartons of food, cartons of clothing. When we get into our constraints, These are going to be the limitations that we have to deal with. We will almost always have x and y greater than or equal to 0, and that is just going to guarantee that I'm sticking within that first quadrant. That's all that that means. Next, I have the total weight cannot exceed 19,000 pounds, so that's going to correspond to this equation right here. And we're given information about weight up in the prompt, so 50 pounds here, 20 pounds here, so 50x, 20y, and it's less than or equal to because we cannot exceed that given limit. And then we have a limitation on the volume, and again they tell us the volume constraints is 8,000, so we have to stay within an 8,000 limit. That's why it's a less than or equal to. Let's see, we have 20 cubic feet, 10 cubic feet. Anytime you see cubic, you're going to be dealing with volumes. So that gives us our constraint equations. Now our objective function is whatever you're trying to maximize. So here it's saying maximize the number of people who can be helped. Well, that's when we're going back and figuring out, okay, how are we helping people? We can feed, we can clothe them. How many with each carton of food and clothing accordingly. And this is going to be the only function that has 3 separate variables in there. So that's how we kind of read through the top half of the answer key. Now what I want to get into is what Miss These Two has down here under where it says graph. Oh boy, that's not what I wanted to do. So under where it says graph, you'll notice she has just random coordinates, it seems. Well, those coordinates actually pair up with the functions from up here, right? So this 20x plus 10y, that's written in standard form, right? So she could go through and she could figure out, hey, what's the x-intercept, what's the y-intercept? And that's exactly what these points represent. That's the x and y-intercept from that blue function. So we have a y-intercept at 800. We have an x-intercept at 400. So this is that line that she was referring to. And it's less than or equal to, so we're going to shade underneath. Similar logic. These 2 points here come from this equation. Also written in standard form, 50x, 20y. So to find my x-intercept, I'll pretend that this is 0. 50 times what is 19,000. Simple arithmetic there. So that's going to give us our x and y-intercepts for this separate function. And again, shading underneath to get this feasible region. So whenever you see those points, those coordinates written underneath the graph section, that's what it's referring to. It's getting the x and the y-intercepts so that we can quickly graph these and not have to putz around with slope-intercept form or y equals mx plus b. And then we get into this mess right here. And all that is just some elimination. You'll see we're multiplying that top equation by a 2, well technically a negative 2, with the intent to cancel out the y so that we can solve for x. And the reason we're doing that is so that we can solve for this intersection point right here. Now, my suggestion to you guys, especially if you're doing this at home, is I would 100% recommend, and keep in mind you can't do this on an in-person quiz or test, but I would 100% recommend using our friend Desmos or some sort of a similar product to find that point. Save yourself some time. Once we get these coordinates of the corners of our feasible region, we're going to want to take each independent coordinate and we're going to plug those in to our objective function. Remember, the objective function is what did we want to maximize. So for this first one, 0, 0, I'd plug in 0 and 0 for the x and y. Clearly, if we're sending 0 cartons of food, 0 cartons of clothing, we're not really going to help anybody. But we want to figure out which one of these would maximize our scenario. So we're going to have to do 4 iterations here of that process since we have 4 corners. And I'm looking for the highest one, and it looks like 4,600 is going to be my maximized value. So that's how we kind of go through and interpret the answer key. All right, so I'll show you one more, just because this is kind of a grosser one, but it's going to be the exact same logic, right? So this one we're talking about shirts and screen printing. This one is kind of tough because you have to really focus in on, there's some small font going on there, right? Where it talks about how much time it takes to make, cost of supplies, profit, all that. So with this one, we're going to look at the last sentence, maybe last two sentences, to figure out what are we using for our variables. So it says t-shirts, sweatshirts, boom, there's our X and Y. And then we're maximizing profit. Anytime you see maximize or minimize, that's a huge indicator that we're talking about our objective function. So we're maximizing profit. So we use P. We have $6 of profit for t-shirts, $20 of profit for sweatshirts. Now with our constraints, we have at most 20 hours to make shirts. So we cannot exceed 20 hours. Okay. Well, if I'm looking down here, I'm not seeing 20 anywhere. So what gives, Mr. D? What the H? Well, if we look over, again, super fine print, got to do some zoomage. We're in minutes, right? So 10 minutes, 30 minutes. So what I need to do is I need to convert 20 hours into minutes. Well, 20 hours, if there's 60 minutes in 1 hour, 20 hours times 60, so 20 times 60, boom, that's going to be 1,200. So that's where that first equation comes from. We want to spend no more, aka less than or equal to, no more than $600 on our supplies. So that's when we're going to take our supply cost from the image and relate that to our function here. And then this one's also different because it throws an at least at us. So at least means we're going to flip around that inequality symbol, because at least means 50 or more. So greater than or equal to 50. Now, when we look at our graph section, we've got all of our points for each individual line given to us, and those are represented on the graph over here. So each one of these pairs of intercepts represents one of the lines, and we've got a handful of intersection points. So we have 4 intersection points, and only 2 of them are actually on an axis. So these 2 are actually on the axis, here and here, but these 2 guys are mysteries. So we need to figure out what are the coordinates of those 2 points. Here you can see that work being done. So what 2 equations are we dealing with? What are those intersection points? So these are the coordinates that we're getting. Again, for this, you can do it on your TI calculator, that's fine, but I would strongly recommend using Desmos or some sort of similar software. Basically anything that allows you to kind of pinch and zoom, right? That's going to be huge to find those intersections without having to putz around with all of the calculation menu options. Once we have those points, we are then going to plug them each individually into our profit equation, our objective function. So each one of these point combinations will get plugged in for X and Y values. And we're trying to maximize here. So I'm looking for the biggest number out of these different profits. Well, it looks like 750 is going to be the winner. And 750 was generated from 75 t-shirts, and 15 sweatshirts. So that's how we go through and interpret this answer key. You guys will have access to this document digitally, so you'll be able to see what all of these graphs look like. One thing that I really want you guys to pay attention to and maybe allow yourself to reflect on why certain things were chosen is keep an eye out on how these axes were labeled, right? Because that's where a lot of people struggle. So are we counting up by 2s, by 3s, by 1s? What's the best way to count up? And to get inspiration for those, I typically suggest looking at your X and Y intercepts here and just making sure that these axes are going to be big enough to include those points. And the bigger your graph is, or the more spread out you have those points, the easier it'll be to see everything. The smaller, more condensed it is, so like this one we probably could have gotten away with counting like every other as one to kind of stretch that graph out. But the more spread out it is, the easier it'll be to see all the information. All right, that's all I've got. That's going to pretty much wrap up our first unit with linear programming here. As always, if you have any questions, please do not hesitate to send me an email. And as always, folks, good luck, have fun, be safe, roll tide.